So I'm going to talk about our 172-year high-resolution ensemble sea surface temperature and sea ice dataset known as HadISST2. This is work I did at the Met Office with Nick Rayner, Holly Titchener. I'm going to try and pick out some of the aspects that make this dataset especially useful for reanalysis, which is what it was designed for in the first place. So how do we make a HadISST? Well, we take some input datasets. We're using in situ data, which gives us a long record back to 1850 and up to the present. Although there are gaps in that data, it's got well characterized uncertainties now. We're using AVHRR data, which is satellite data from the HadISST2 Climate Change Initiative project. This is satellite data with good coverage, well quantified uncertainties, and it's very clean, kind of easy to use data set. We have ARC data, which is from the long track scanning radiometers, very accurate satellite data set, which is going to give us additional stability in the data post 1990. Then we have information from passive microwave and sea ice charts, which is going to give us sea ice information that's used to estimate SSTs in the marginal ice zone, as well as sea ice concentrations. We have to bias adjust each of these independent data sets, so the in situ data are bias adjusted using the method we developed at the Met Office. The AVHRR data are then bias adjusted relative to the in situ data. And then the different data sources are combined to give a combined in situ satellite data sets used for reconstruction. So we do reconstruction in two steps. We do a large scale reconstruction using an iterative EOF based method to produce large scale reconstruction using large scale patterns of variability. And these are estimated from the GAPI data iteratively. We do this at low resolution, so we can make full use of the uncertainty model in the in situ and satellite data. And then we scale those patterns up from 5 degrees, where we do the initial analysis, up to 1 degree, so we get extra detail in those fields. We then use those as a basis for a mid-scale reconstruction. We analyse the residuals from large-scale reconstruction using a simple optimal interpolator with varying spatial length scales and variance. And then we combine these, drawing samples from each to generate an ensemble. And so the ensemble is useful for reanalysis as it expresses uncertainty in the underlying SST fields, and you can use it for running an ensemble of reanalyses. One thing in the latest version of HadISST we have here is the ESA Sea Surface Temperature Climate Change Initiative AVHRR data. It's got relatively small biases compared to previous AVHRR data sets. Even before bias adjustment, those biases are less than around 0.3 of a degree in most cases, less than 0.2 of a degree in many. And then after bias adjustments, the biases are virtually zero, so much less than 0.1 of a degree on a global scale. So we use the combined in situ and satellite data to do this large-scale reconstruction. We initially do this at low resolution, so have some of the estimated EOFs here at 5 degrees on the left-hand side, the first 3 EOFs of the analysis. We do this at low resolution so we can make full use of the uncertainty analysis. We then scale these up to 1 degree using the full in situ and satellite data. That's shown in the middle column, and then we smooth these to remove kind of ship track artifacts that appear in some of the EOFs, unfortunately, on the right-hand side here. So that gives us a large-scale reconstruction at 1 degree. We use this as the basis for doing an analysis of the mid-scale variability. So this is a local optimal interpolation, which has got 4 parameters, a standard deviation, and 2 length scales, Lx and Ly, Lx being the longer, and then theta, which is an angle from the zonal direction in which these Lx and Ly axes are rotated. So this gives us a lot of flexibility in the local OI field to pick out some of the interesting features, such as western boundary currents, coastal features, and so on, that aren't necessarily picked up by a homogeneous isotropic local OI. So we combine the large scale and the local to get the full analysis. So we put it all together here. So just to zoom in, we have some observations for September 1976 at 1 degree resolution. See there's large gaps. We do the large scale reconstruction, that's panel B. See we're picking up many of the broad scale features of that observed field. We combine large scale and mid scale reconstructions down in panel E there, and you can see that we've picked up a lot of the details, but some regions, particularly in the Southern Oceans, are still lacking detail. And we recover some of this by sampling from the posterior distribution of the large and local mid-scale reconstructions, and we get panel H there. And then we combine that with the marginal ice zone temperatures to get a full analysis on the bottom right-hand side in panel I. We have generated an ensemble of 20 versions of this that can be used for reanalysis, running atmosphere-only models, and so on and so forth. So that's the HadISST 2.3 data sets. Nick Rayner will be presenting the poster, so if there are any other questions, then I'm sure be happy to answer those. Thank you.